It is a tall spar, a pole, which is erected vertically on the center of the sailboat, where the mainsail and boom sail meet, and also where the jib is located as well. The mainsail is a sail located behind the mast of a sailing vessel. The foot of the mainsail is usually attached to the bottom. The jib is usually smaller than the mainsail and allows the sailboat to fight against stronger winds. The boom is a spar along the foot. Foot means bottom, control of the angle and shape of the sail. The primary action of the boom is to keep the foot flatter when the sail angle is away from the centering of the boat. The tiller attaches the rudder to the hull and provides torque in order to turn the rudder and steer the boat. The hull is the body of the ship that is watertight and varies in shapes and sizes depending on the boats. The keel is connected to the bottom of the hull. It has the two functions of preventing the boat from being blown onto its side by the wind, as well as holding the ballast that keeps the boat right side up. The rudder is on the back of the hull, connected by the tiller. Primary function is to steer the ship or boat.
A monohull is constructed of one hull, a catamaran is constructed of two hulls, and a trimaran is constructed of three hulls. Second, you have the keel type, which includes a fin keel, wing keel, bilge keel, daggerboard, or centerboard. A full-length keel, often found on traditional sailboats, uses length rather than depth to provide an adequate lift and ballast for the hull. Sailboats with a bilge keel are often able to stand upright on sand or mud at low tide. They are very common in areas of large tidal ranges. Bilge keels are not often as affected as center keels in reducing sideways spillage known as leeway. Centerboard and daggerboards are able to be raised and lowered by the crew. When raised, they both reduce draft and wetted surfaces. When lowered, they both provide many of the same benefits. Smaller boats, they are often unstable. A centerboard is attached to a boat by a pin that creates a pivot point for lifting. A daggerboard drops into a slot through the boat. The purpose of the daggerboard or any keel is to balance the force of the wind on the sail. Without a keel, the sailboat cannot sail upwind and can simply be blown sideways. Finally, you have the mast configuration and sails, which include the sloop, fractional rig sloop, catcher, schooner, yawl, cutter, and cat. Sloop is the most common type of sailboat. It has one mast and two sails, a mainsail and the headsail. Depending on the size and shape of the headsail, it may be called a jib, genoa, or a spinnaker. The forestay on the fractional rig sloop doesn't reach the top of the mast. It connects at the lower point. There are performance advantages to this setup, since the fractional ridge allows the crew to bend to the top of the mast and flatten the sails on a windy day when full power is not needed. A ketch has a second shorter mast behind the main mast, but forward of the rudder post. The second mast is called the mizzen mast. A schooner's aft mast is taller than its forward mast. Schooners may have up to 6 masts, though mostly only have 2. A cat ridge only has one sail, and the mast is located well forward. This is a popular ridge on smaller boats, which are known as cat boats. The slowest way to position your boat would be straight into the wind because you're not generating any lift. The second slowest would be dead away. The sail is very limited. When you're going away from the wind, the wind cancels out the actual wind because you would only be able to match the actual wind. The sail would have no force.
The sails actually act like wings, generating high pressure on the inside of the sail and generating low pressure on the outside of the sail. Then you generate lift, pulling the sail sideways and a little forward.
A sailboat can go faster than the wind if the sail is about 40 or 90 degrees angled into the wind. The apparent wind on a sail creates a total aerodynamic force, which may be resolved into drag, the force component in the direction of the apparent wind, and the lift, the force component normal to the apparent wind. As you can see, there is a positive force against the inside of the sail and a negative force pulling on the outside of the sail.
It is traveling faster when the sails are on the outside.
To To travel into the wind, you first have to be traveling perpendicular into the wind. Then adjust the rudder so you are going diagonally into the wind. After a certain point, you use the rudder to turn fully parallel into the wind. You then adjust the jib as the mainsail catches wind and then turn the rudder to travel diagonally into the other direction. Then you repeat this process by going in a zigzag motion.